wanted to follow up on what we can do exactly with different variable types. So last lesson was basically just a little introduction to programming, give you a little bit of at least a couple different things that you can start thinking about when you write your programs. For this lesson, we're going to go more in depth with different variables and operators. So let's say we have let A equals 1, let B equals 2. And then you saw in the last video, we can obviously add these together. So if you print A plus B, actually let's make a let C equals A plus B, just so it's more clear, and print out C. So C equals A plus B, excuse me, which is 3. And that's cool. We can also do minus, so A minus B. And I'm just going to leave this in the comments after. So we had the plus, we should do that. We had the minus. What if we do A divided by B? So A divided by B, I don't know why that got in there. A divided by B, what do we expect? So 1 divided by 2, obviously 0.5. But because these are actually integers, it won't work exactly like that. So we expect 0 for the result of A divided by B, because C is also an integer which can't have a decimal. So just like A and B, C also has to be an integer. Okay, so what if we want to actually get 1 divided by 2? So in that case, we'd have to make these both doubles, so they would be able to have a decimal place. And then C would also have to be a double as well, and we should get 0.5 at this point. So if that makes any sense, you know how that works. So C is a double because A and B are doubles pretty much. Swift is smart enough to know that. We can also multiply. So we expect 2 in this case. So 2.0. And we'll go back to this and just comment this out. A times B was 2.0. And the last general operator for numbers would be modulus. So modulus is basically, let's take the remainder. So for A and B, floating point numbers, use truncated remainder. Okay. So it doesn't like the fact that these are doubles because Swift has its own special way to get the modulus of that. So let's make this 15 and let's make this 4. So what a modulus basically does is it's going to divide 15 by 4, which would be able to be divided by like 3 point, I don't know, what is that? 3.5 times or something? Does that work? No, almost 3.5. It's close enough. But basically what it does is, what's 15? Sorry. Divided by 4. I can't believe I'm doing it. 3.75. So it would be, let's make this just 19, just to give you a better idea about how it works. Okay, so 19 divided by 4, which would be 4.75. So we should still expect 3 at this point, because what it does is it takes a remainder, like 19 divided by, let me make this a comment really quick, 19 divided by 4 equals 4 remainder 3, correct? So modulus just tells you what the remainder is. So it's a handy way to do that with integers. It's very useful in programming. You might not see the use case for it right now, but it's good to know that that exists. We can also compare two values. So if we want to compare A and B, let compare sin equals A equals to B. So we're going to print comparison, and I'm missing an R in there. All right. Comparison A equals B. So this is the same thing. Let A equals 19. But we're going to say let comparison equals A equals B. And so equals B basically says is A equals to B. Because in programming, the equal sign already is used for assigning whatever's on the right-hand side to the left-hand side. So we have to use 2 equals sign to actually get this comparison. So does A equal B? No. Let's run it, and okay. Let's just comment this line on as well, and run it. So false. It prints out false. False is what's called a Boolean value. So a Boolean value could either be true or false, and we signify it like that. Let comparison, which is a Boolean value, A equals to B. Cool. Now what we can do is we can also say is A greater than B. And so that would be true. So comparison prints out true. We have less than B, and run that. We also have less than or equals to B. That works as well. And we have greater than or equals to B. And A is greater than or equals to B, true. So if we change this to 19 and run it, whoa, we get true. But if we get rid of the greater than or equals, we should get false, because it's not greater, it's equals to. And if we go equals B, true. So A and B equals each other. So that's a quick introduction there. We covered dividing integers, we covered dividing doubles, and we covered Boolean values and comparing pretty much number values together. Same comparison works automatically as if these were doubles. And we should expect that this is true as well, but sometimes how different programming languages and the compiler handles that, it likes to make this like that or something. And if you do that, they're not exactly true. So you have to be careful with this later on. You won't really come across it so much now, but just know that that's a problem that could exist.